One.
Good afternoon, everyone, or morning or evening. This is the beginnings of Unit 4 out of 6. A very short unit. This one will take us, in calculus here, this one will take us maybe not five, maybe 7 lessons or so. It's just graphing with the help of derivatives. So we look at something called the first derivative test and the second derivative test of curves. And then we use those to help us out. As we know, derivative of a particular function represents the slope of that function at that point, okay, at a particular point that you're going to be subbing in. So that derivative helps us tell us the slope. And when we do the second derivative of that, it actually will tell us something else, which we'll get to later on. Talks about, I might as well tell you anyway, it talks about concavity. So we're going to be looking at the first and second derivative test, and then using this first and second derivative test to help us sketch curves. Okay, so what they look like, and getting the full curve now, so you don't have to go like we did in Pre-Cal 30, where when you were sketching curves, you had to kind of make estimates and things like that. This will make it a lot easier, actually, to know the slope and the concavity. So it's going to be a short unit. Okay, you might still be working on your derivatives hand in, or possibly you might be preparing for the derivatives test, which was a long unit, 15, 16 lessons in there, something like that, not including the work time that we had. This one will have about 5 to 7 lessons. Okay, so let's get started here, what we're going to do today. And this is going to be unit number 4, A1. And this is basically curve sketching, using derivatives to help curve sketch. Or just, I guess it's not to help, to curve sketch. Notice I didn't say curve plot. We're going to be just making general sketches. Okay, so the first thing I want to say is it's similar to what we did with limits, except now we don't have to worry about finding horizontal and vertical asymptotes with limits, even though that's still part of what we're going to see here. In the curves that we're going to see today, or the first few curves anyway, aren't going to have any asymptotes in them to start with. Okay, so the limits technique that we used to plot curves was for plotting curves that were rational. Okay, that means they had a denominator over a numerator, and you could have horizontal and vertical asymptotes. This is a different kind of curve sketching that we're going to start with. We're going to be looking at sketching polynomial curves that are continuous, like powers of 3, powers of 4, powers of 5x. So there's going to be turning points and intercepts and maximums and minimums and things like that. Okay, so we're going to be looking mainly at polynomial curves, or equations, if you like. Okay, so that's what we're going to focus on with this curve sketching technique, because that derivative is going to help us find the slope of these curves. So let's start off with what we want to look at today. So today in lesson 1, I want to look at a couple of things. I want to look at the first derivative test and how you use the first derivative test to find maximum and local maximums and local minimums, and how to decide whether it's curving up or down and things like that. So that's where we're going to start today. I'm just going to move this over here to the other side. That's my preview, so I can see what we're doing. Okay, so our outline for today is talk about something called critical numbers. Find critical numbers, okay, and look at or find or use, I guess would be the best word, use sign analysis to help, or to find, not to help, to find max and min values. Of the And that's what we're going to do. I'm going to do some examples in there as well. And like I said, I'm trying to keep it to that 30 to 35 minute range here to help our students out that are doing the shorter 45-minute class for their online. Okay, so what we want to look at first of all is let's start off with the first derivative test. Okay, let's try a different color for effect here. The first derivative test. Okay, what is the first derivative test? Oh, and well, we'll put in and critical numbers. So let's start off with critical numbers. That's the easy one to start with. So when we're talking about a critical number, I'll go back to black here. When we're talking about a critical number, it's a number of x on the graph where it's defined where it's a point where the derivative of the curve is equal to 0. Because as we know, when derivative represents slope, so when we have a slope of 0, that means we have a flat point. Okay, that slope will have to be horizontal. Horizontal slope tells us that that's going to have to be a peak or a valley. So we can find a maximum or minimum value. Okay, so a critical number, sorry, I'm on the wrong side here. Cursor back to the right side. Okay, all right, so and I'll draw it out as well here. A critical number for a curve, okay, so graph of a curve, obviously, is a point where the derivative of the curve is 0. You got a question or?
No, I was just giving you something, so I was copying. It's on your desk.
Okay.
Is that yours?
Yeah. Okay, so it's where the derivative is 0. Okay, so that means that you're going to have that flat spot. Okay, it's usually where a maximum or minimum curves, but not always, because you could have kind of a inflection point there as well, where it's changing from one curve to another, so it could be a flat part. So we'll say max min areas. Okay, so let's take a look at what I'm talking about graphically here. So what we're talking about here is if we have, say, a hump, a maximum point, a local maximum they call it, if it's looks like this. So we'll take our marker out here. Let's make it this skinnier so we can see a little bit better here. Okay, so if I have a graph that's got a hump part like this, and if we have at this point here a critical point here, okay, so this C is a critical point on the curve. Okay, so that's C value there. Because we could see that if we had, if we just draw a tangent line there, that tangent line, we can see that the slope of this curve, we'll call it y prime, okay, so y prime, or whatever that curve is, the derivative of that curve is 0 at point C. We have a flat slope. Before it, if we go to a point before it to the left of point C, we'll call it point A. Okay, and we'll go to the right of it at point B. Now let's make a little b there instead of a big B. Let's try to be consistent here. Okay, so these are x points, obviously, A and B are. So at point A, we can see that the derivative at point A, if we were to draw a tangent line of the slope here to represent the slope, so let's go back to our red line here. There we go. If I were to draw the slope, I gotta kind of, there we are. We could see that that slope is actually positive, correct? It's climbing from left to right upwards. So that means the slope is positive. So that means that the slope, the derivative is positive point at point A, so it's greater than 0. So that derivative, oh, stupid, I always have to change. Why doesn't it just stay there? It's greater than 0. So we can say that at point A, okay, so we see that we have A greater than 0 slope, 0 slope, less than 0 slope. As we go over here now, and I draw the tangent line for the B part here. See how the slope here at B is going downwards now? Okay, so at point B, we have a slope that is less than 0. So y prime is less than 0 at point B. Okay, remember y prime representing the slope and the derivative. Okay, because the derivative is the slope at the curve at that particular point. So that means if we go from plus to 0 to minus slopes, which we mean value for the derivative, remember, we have what's called a local maximum. Okay. That's a local maximum. We'll go from positive to 0 to negative. Okay. And that critical number is where the derivative is 0. So that's going to be a flat spot in the slope. Okay. The opposite is true for a minimum. Oops. I just want it to go down. Okay. So if we do a minimum, we could draw this minimum here. Like this. Okay. Okay. C is there. Another critical number. Let's not use A and B this time. Let's use E and F for this graph. So if we draw out all our points and get our line maker out here, okay, here we have, look at that, negative slope there, 0 slope there, positive slope here. Okay, gotta line it up here. Okay, so we see that in this case we have the exact opposite here. Here C y prime is equal to 0 at C again. So that's a critical number. Okay, here we have y prime being less than 0, right, at E. Here we have y prime being greater than 0 at f. Okay, see, it's going up. So it's got a positive slope, negative slope. So when we go from negative to 0 to positive slope for the derivative, so that's a derivative value. Okay, we have a local minimum occurs. Okay, so that's how you find local maximums and minimums. And we do a sign analysis to do that, and I'll show you an example of that right away. So we look at a derivative and we take the derivative. Wherever the derivative is equal to 0, that's going to be our point of flatness. And then we look on the left and right side of the derivative to see if we have positive or negative slope values. If we have negative, then positive, well, then it's going to end up being this one, the u. If we have positive, then negative, then it's going to be the n, right? Or the hump, or a valley, right? So that's what we're going to do next. That's basically the first derivative test. So let's take a look at an example now. Okay, so let's do that on our second page here. See where we are in time. Okay, about 17 minutes in, so about halfway down. Okay. Okay, so let's do an example. For the curve, let's type here. Find example number 1 here. Find the critical points and local max and min points. For the curve, okay, let's put the curve in here. I'll have to make one that works out here. Let's look at my examples over here. One that'll work out nice and even because we don't want to use the quadratic formula yet. Okay, so let's say we have y equals 1/3 x cubed. You can see what I'm trying to do here. I'm trying to make it balance out nice when we take the derivative. X squared minus 3x plus 1. Okay, so the first thing that we do is we take the derivative and equal it to 0 to find the critical points. So step 1, I just want to change color. Step 1, take the derivative, can't spell today, or any day. Derivative. Oh man, I can't spell it all today. Here, let me get this right here. One more crack at her. I'm used to typing it. There we go. Take the derivative, okay, and equal it to 0. Okay, that gives us the critical numbers. Okay, that's going to give us the flat spots. So you can have a maximum or minimum. So the derivative of this is 3 times 1/3. That would be 1, x squared. This would be plus 2x minus 3. Okay, so there's our derivative. So then we equal it to 0. So derivative equals 0. Okay. Okay, now we have to factor or use the quadratic equation if we can't factor it. This one I purposely made so we could factor it. X plus 3, I guess, and minus 1. So x equals negative 3 is a crit, and x equals positive 1. These are two critical numbers. So then to get our critical numbers, we'd have to sub it back into the original equation, right? If we want to get the full number, okay? Okay, y values. Do we need the y values right now? No. We don't need the right y values right now, but we would when we're doing curve sketching. So just remember that when you want the y values of the curve, it's not this curve. This is the tangent line. Okay, this is the actual curve. So you would plug this back into here to get the actual values. Okay, so step 2, after you get that, okay, step 2 is to do a sign analysis on the derivative. Okay, so how do we do a sign analysis? Well, it's just like we did back in 30, pre-cal 30. So we take the derivative and we're going to do a sign analysis on the derivative. So here's our line. Okay, and we have two critical points. Two critical points are placed on the line at x equal negative 3 and x equal 1. Okay, so those are our crits. Okay, then we analyze what happens to the curve point. Now we could do this the whole curve here and see what's the value of this curve below negative 3 and above it, and then below 1 and above it. So we could just use this whole curve here, or we could do the sign analysis of the two factored points. So let's just do the whole curve. Sometimes you do it with each of the factors. Sometimes you do it with each of the whole curve. Now, what I usually do is I do each factor so that we can get our 0 points. Okay, so let's do it that way first. So if we take x plus 3, okay, that's 0 right there. Okay, below that it's negative, right? If I put in x equal negative 5, I'd get 25 minus, negative 4. If I put negative 4 in there, negative 4 plus 3 is negative 1. So I'd get a negative value over here, right? For that particular factor. And then it's positive above that. Okay, don't do the whole curve until, you could do the whole curve here as well. Then I do x minus 1. Okay, x minus 1. So that's 0 right here. That's where our two critical points are. Okay, and x minus 1, if we're below 1, like a 0, if we put a 0 in there, we have a negative 1 again, a negative value all the way up there, and then a positive value here. So for the full curve, for x, now you could have just did this one only if you wanted, but then you'd have to know where the critical points are. So this is positive here, two negatives there, make a positive. This negative times a negative makes a positive. Positive times a negative makes a negative. Positive times a positive makes a positive. Okay, so this is going to tell us what we have here. So we are going, okay, so at the -3, we're going positive, flat, negative. So this is a max. Okay, and at the 1, we're starting out with negative, flat, positive. So this is a min. Okay, so then we have at x equal -3, we have a max value. Okay, so we have to find the y point. So let's find the y point. Y equals 1/3 x cubed, what was it? Plus x squared minus 3x plus 1. Make sure I got that. Okay, so then I put in 1/3 times -3 cubed plus -3 squared minus 3 times -3 plus 1. So that'll give us our y point. So if we put in all of those, we're going to get -27/3, so that's -9, +9, +9, and +1. So that gives us, what do we get there? 0, 10. So we have a max value at -3 and 10. So there's our max value. And over here we have a min value at, okay, let's move that up so we can see it. Okay, min value, what's the point going to be there for the y? 1/3 times 1 cubed plus 1 squared minus 3 times 1 plus 1. So this would be 1/3 plus 1 minus 3 plus 1. So we got 1/3 minus 3 plus 1 plus 1, so that'd be -1 there. 1/3 minus 1 is -2/3. So we'd have a min at 1. And was it -1 or 1? No, it was 1. Good. And -2/3. A min val. And that's how we find maximums and minimums, basically. Pretty straightforward. So let's do one more here, and then we'll give you some practice. Let's do a simple one. Maybe one that's doesn't give you a quadratic. Let's say we have, okay, y equals, same idea. Okay, you work out the same thing. Y equals x squared minus 8x minus 20. So this is a quadratic. Okay, so you can pause it there and give it a try. Where you're going to get a maximum or a minimum. Find the point where it's maximum and minimum. Find the critical point and find the max and min points. Okay. Now I might say, where is it increasing and decreasing? Before you pause for that, maybe you unpaused it already. Okay. Sometimes the question will ask you, what are the intervals of increase and what are the intervals of decrease? So let's go back to this one for a sec. Okay. If I asked you that, okay, it's increasing from, if we look at it, it's increasing from -infinity to -3. So if we do interval notation, well, I have to do marker here. Sorry guys. It's increasing from -infinity to -3 doesn't include that because it's 0 at 3. And it also increases from, if we look at the graph, it's also increasing from 1 to positive infinity. Okay, that's the interval of increase, decreasing, because sometimes I'll ask you that. It's decreasing. Where's it decreasing? From -3 to +1. Okay, so if I asked, what is the interval increase, decrease? You could do it that way. Okay, so let's go back to our question here. Okay. Give it a try. Okay, so if you give it a try, we had to take the derivative first. So this is 2x minus 8. Okay, so we have to say 0 equals 2x minus 8. Now we have to solve for x. So that's pretty easy. Bring the 8 over. So x is going to equal 4. So we have a critical point at 4. Okay. Okay, so if we do our sign analysis, it's only one critical point. Okay, and basically our derivative, in this case, it's 2 times x minus 4, if you like. Okay, so that's why we get our 0 here. Okay, so below that, at 3, 2, 1, 0, it's negative. Above that, it's positive. And that's all we can do because there's only one factor, right? So then it's going negative, flat, positive, right? Negative, flat, positive. So we have a local min at x equal 4. Okay, so let's find out what y is. What does that give us? 36 negative? Okay, so we have a local minimum at 4, negative 36. So that would be our vertex points. So now you can find vertex points of quadratics without factoring those. If you know how to do the derivative, you can just simply factor the derivative, which is pretty much easier. Okay, so that's an example of critical numbers and critical points. Okay, so for our assignment here, let me pop it up here. I think I got it here. Oh, no, that's extra notes there. Wrong one. Okay, let's see. So if we're, for our practice assignment, I'll maybe scan this one in here for you guys. Give me a second to pop it up here. I think I've got 6 of them here. Where are we here? There it is. Okay, so called the very first derivative test assignment. Here, it's in Word right now, but I'll scan it in. Okay, so here's one cube, here's one a cube, here's one the fifth, here's one, here's one, here's one. So remember, maybe we should, like for this one here, you're going to get 4x cubed minus 3x squared. So don't forget when you're factoring, you can take out common factors first, okay, to get your points. If you can't factor something to work it out, then you have to kind of use, sometimes you might have to use the quadratic equation or something, but most of these should be able to factor for you. So you can work on that. Just says find the critical numbers and the intervals of increase, decrease. I don't like that as much as I like find and the maximum, minimum. But increase, decrease would still give you the maximum or minimum, as long as you do it correctly. So that's it for today. Work on those practice. Next day, we'll be looking at the second derivative test, which gives us concavity.